Welcome, everyone. Today, we are going to explore a fascinating and essential topic in research methodology: research motivation. If you have ever wondered how scientists spend years or even decades working on a single problem without giving up, you are in the right place. We will uncover the psychological engine that drives human curiosity and learn how to actually calculate the drive to succeed. Let us dive in. Now that we know what we are studying, let us visualize the research process. Imagine you are standing at the base of a massive, steep mountain. Climbing it will take months of exhausting effort, and there is absolutely no guarantee you will safely reach the top. Why would anyone choose to make that difficult climb? In the academic world, conducting research is very much like climbing that mountain. It requires late nights, dealing with failed experiments, and reading hundreds of complex papers. The invisible fuel that keeps a person moving forward through all these challenges is called research motivation. Without this inner drive, the journey of discovery would simply be too difficult to complete. With that metaphor in mind, let us look at the formal academic definition. Research motivation refers to the internal and external driving forces that compel an individual to undertake a systematic, rigorous inquiry into a specific problem. Think of it as a psychological catalyst. It is not just about starting a project. It is the energy that initiates, directs, and sustains research behavior over a long period of time. Ultimately, research motivation is exactly what transforms a simple, passing question in someone's mind into a highly structured scientific investigation that actively adds to human knowledge. Understanding this definition leads us to ask, where do these driving forces actually come from? Researchers are typically driven by two main types of factors. First, we have intrinsic factors. These come from within, such as pure intellectual curiosity and the deep personal desire to discover unknown truths. Second, they are driven by extrinsic factors. These are external goals or rewards, such as the need to solve practical societal problems, earn a university degree, secure a career promotion, or gain respect among peers. Most successful scientists rely on a healthy mix of both intrinsic and extrinsic motivation to keep going. Now that we have identified where motivation comes from, we must understand why it is absolutely critical. The reality is that the research process is inherently filled with setbacks, rejections, and dead ends. If a researcher does not have a strong underlying reason for their work, they will likely abandon their project at the very first sign of failure. Furthermore, strong motivation ensures that the researcher maintains high ethical standards and rigorous methodology. Instead of taking lazy shortcuts just to finish the job, a motivated researcher cares deeply about the accuracy and integrity of their final results. This commitment to rigorous methodology is exactly what has shaped our modern world. The greatest breakthroughs in human history, from the life-saving discovery of penicillin to the invention of the internet, were driven by highly motivated individuals who simply refused to give up. They faced countless failures, but pushed through because their drive was stronger than their obstacles. Without research motivation, scientific progress would completely halt. No new medicines would be found, no new technologies would be developed, and society as a whole would stagnate. Motivation is the true engine of human progress. Seeing how vital this engine of progress is, you might wonder if we can measure it. To truly understand how motivation works logically, We can borrow a famous psychological model called Vroom's expectancy theory and apply it directly to research. This model is fascinating because it breaks the abstract, invisible concept of motivation down into a simple, calculable equation. By quantifying human desire and belief, we can actually predict how likely a researcher is to pursue a specific topic. This mathematical approach helps universities and funding agencies understand how to better encourage and support scientific discovery. This brings us to the mathematical representation of Vroom's theory. The formula states that M equals E times I times V. Let us break down what each symbol means. M represents the total research motivation. E stands for expectancy, which is the researcher's belief that their hard work will actually lead to a successfully completed project, measured on a probability scale from 0 to 1. I represents instrumentality, the belief that completing the research will definitely lead to a specific reward, also measured from 0 to 1. Finally, V stands for valence, representing how much the researcher personally values that final reward, measured from -10 to +10. Because these are multiplied, if any single factor drops to 0, the total motivation becomes 0, and the project will not even start. Now that we have our formula, let us see this with a concrete example. Consider a graduate student named Sarah deciding whether to research a new water purification method. We are given that she is very confident in her laboratory skills, giving her an expectancy of 0.8. She knows completing this will definitely earn her master's degree, so instrumentality is 1.0. She values this degree highly, assigning a valence of 9. We are asked to find her total motivation. We choose the expectancy formula and substitute our values. We first multiply 0.8 by 1.0, which remains 0.8. Then we multiply by 9. The final answer is 7.2 out of 10. This high score means Sarah has a strong, healthy drive and will likely push through any lab obstacles. Let us contrast Sarah's situation with another practical scenario. Consider a veteran scientist, Dr. Aris, who wants to research a cure for a very rare, complex disease. Because it is so difficult, his belief in success is low, giving an expectancy of 0.2. However, if he succeeds, it will absolutely save lives, so instrumentality is 1.0. Saving lives is his ultimate goal, giving a maximum valence of 10. We want to calculate his motivation. We substitute these values into our equation. Multiplying his low expectancy of 0.2 by the certainty of 1.0 gives 0.2. Multiplying that by his massive desire of 10 gives a final answer of 2.0. Physically, this means his overall motivation is quite low, simply because the chance of success is so small. This mathematical result from Dr. Aris's example leads us to an important real-world observation. Even though the reward of saving lives is incredibly valuable to him, his overall motivation score is quite low. This perfectly illustrates why many researchers avoid extremely high-risk projects. When the expectancy of success drops too low, it drags the entire motivation score down with it, no matter how great the potential reward is. To fix this, universities and institutions must provide extra support, mentorship, or funding. By doing so, they artificially increase the researcher's expectancy of success, which in turn raises their overall motivation to take on difficult, world-changing problems. To solidify everything we have discussed, let us look at this visual flowchart of expectancy theory. On the far left, we start with research effort. The arrow connecting effort to research performance represents expectancy. which is the belief that your hard work will actually result in success. Moving to the right, the arrow connecting performance to the final reward represents instrumentality, the belief that your success will be recognized and rewarded. Finally, the final reward box itself is tied to valence, which is how much you personally care about that degree, discovery, or promotion. As shown by the formula at the bottom, all three of these links must be strong for the entire chain of motivation to hold together. We have covered a lot of ground today, so let us review our key takeaways. First, research motivation is the essential psychological engine that drives the entire scientific process forward. Whether fueled by pure curiosity or career advancement, it is the only thing that keeps researchers working through inevitable failures. Second, through expectancy theory, we learned that motivation requires a strong belief in success, a clear path to a reward, and a reward that is deeply valued. By understanding these components, we can better support scientists. Ultimately, a highly motivated researcher is the most powerful tool we have for solving the world's greatest problems. Thank you for watching, and keep exploring.